Welcome to Mimi's Math channel. Today I'm going to discuss transforming quadratic functions. We're going to look at the quadratic function that's in vertex form. I'm going to color code as well as explain the different variables a, h, and k. For example 1, I see that I have f of x, which is all in blue, and then I'm trying to change it to g of x. What I notice is I'm going to take all of f of x and then I'm going to add 3 to it. If I look at f of x, that includes an h and a k, but if I look at my g of x, it only has a k. The easiest way to do this is to substitute in this portion of my f of x right here, and then combine my -4, which is the k for f of x, with the +3, which is my g of x, and this is what the final answer will look like. I took all of f of x and I put it in parentheses, and I put it in the place of f of x. However, g of x asks me to add 3. What I'm doing in essence is just combining my k values. The f of x portion, the quantity of x minus 1 squared, does not have an h in the new function, so therefore I can just bring it down. -4 plus 3 simplifies to -1. That is my new function g of x. Example 2. We still have an f of x and a g of x. We're going to substitute the entire f of x where it is asking for f of x and g of x. However, I notice that I have an h and I have a k. I'm going to take all of f of x and I'm going to replace it where g of x says to replace it, but g of x also has an h, which is -5, and it has a k, which is -2. I'm going to keep that, and I color coded it so hopefully you can see what's happening. I take my quantity of x plus 2 squared and I put it in blue, but again I have to combine that -5 that is in my new g of x, and then for the +1 portion, which is my k, that goes on the outside, and I already had a k on the outside for g of x, which is -2. Inside of my parentheses, I just combine that, and that's going to be -3. On the outside where k is, I have 1 minus 2, and of course if I combine that, that's -1. I do want to show you in Desmos what that would look like. I want to go from -2, 1 as a vertex, and then I want to move over to the right 5, and then down 2. Going to the right 5, 1, 2, 3, 4, 5, and down 2, 1, 2. That is my new vertex for my new function. This is how you can actually verify in Desmos. In example 3, I have a negative now. My f of x has already taken into account that negative, so I do not have to distribute that. Keep that in mind. We are, however, going to take all of f of x and we're going to substitute it here. The only thing we have to do this time is combine the h's. We don't need to combine a k because there's a 0k here. What I did now is, again, I took the entire f of x, and it may help you if you just go ahead and put parentheses in it, and you take all of that and you substitute it in where g of x is asking for f of x. You just have to remember to leave some space inside of the parentheses because we also have a +4 in our new function. This is what it will look like. And once I combine the 1 plus 4, again, I do not have to distribute this negative because it was already accounted for in my old function. X plus 1 plus 4, we simplify and we have the +5, and then you just bring down the +2 since there was not a k to actually include with it. This is my new function. If you wanted to test it, you can put this in, and see if it in fact did move over based off of what you were asked to do. So this time, g of x has the negative sign. So if that happens, you will have to distribute this negative if your original function f of x has a k. So keep that in mind. That's the difference between example 3 and example 4. Example 3, again, the original had the negative, so it was already accounted for. I'm going to keep the negative, the +2, which is my h, and the +8, which is my k, and I'm going to keep that in orange so you can see what's going on. Then I'm going to take all of f of x and I'm going to replace it for the f of x that's shown in g of x. However, the parentheses portion, I'm going to put with the +2 that's already there. So that looks like this. And then I'm going to take the -6, which is on the outside, my k, and I am still going to put it next to the parentheses squared. But let me just show you, this is all at x. So all of that is going to go inside of parentheses. For instance, let's go back to something that you already know. If I ask you to substitute in for this, and you know know that x is going to be 2, you wouldn't write it like that, right? What you would do is you would actually put the 2 inside of parentheses. That's what we're doing. So in green, I'm showing you that I am putting all of f of x in parentheses so that you can see why -6 is the only k that's going to be affected by this negative. Why not 8? It is outside of my parentheses. However, once I change that, I do have to combine the k's together. This is what my final answer would look like. As I've written here, you just really want to pay attention when a in your new function has something out front. That's when you have to distribute it to your original function. For example 5, we're going to see that our new function does have something on the outside that represents a. However, it's a number. It's not the negative sign this time. We're going to take all of f of x. We're going to replace this portion f of x. Don't forget, the h's will be combined. Your k's will be combined. However, your k will be affected by what's outside of your g, just like in example 4. I find it helpful to color code. And for my f of x, I also find it helpful to go ahead and put that in parentheses, because that way you can see everything that is going to be affected by whatever is on the outside for the new function g of x. If I have my parentheses around just this portion, that means that this k from my new function is not affected. You might also say, well, why are you not distributing to the binomial squared portion? So let's go back to example 4. If I were to distribute the negative to the x and to the 3, I'm going to have a negative x minus 3 squared. Well, I know I can factor out the GCF of negative, so I'm just going to end up right back where I started, which is here, because I'm going to take this negative out, and that will leave me with x plus 3, right back where I started. So you never want to distribute this negative to the binomial squared portion, only to the part that's left over, the k. And the same thing here, I wouldn't want to take the 2 and multiply it times the binomial squared, because I'm going to end up having to take out the GCF, which is going to end up leaving me right back where I started. Here, I took 1/2 of 2. 1/2 of 2 is just 1. When I'm showing my final answer, I don't have to put the 1 there, it's understood. And here, I see that I'm just going to simplify it, so I have x plus 4 minus 1. 4 minus 1 is 3. That's where the positive 3 comes from. And over here, this negative 1 is affected by that 2 that's on the outside. So 2 times negative 1 is where this negative 2 is coming from. But I already had a plus 5 in my g of x. So therefore, once I combine that, I'm going to have a positive 3. The original function f of x is the one in red, and it showed us that we had a vertex of -4, -1. And I show my students, yes, h and k are the vertex, but it's easier for them to understand h by trying to recognize what would x have to be to make this equal 0. Once we perform our calculations over here, you're going to see that this simplifies down, and now my new vertex is going to be -3 and +3. Thank you for watching. Please remember to like and subscribe. Have an amazing day.